Okay, I'm going to try to take you through a couple of these genetic problems here. And here we have a blood type problem where we have Mr. and Mrs. Smith and Mr. and Mrs. Jones. The Joneses and the Smiths basically have a baby at the same time, and at the excitement of the baby's being born, nobody puts wristbands on the baby, so they don't know. They're both girls and they don't know which baby goes with who, and so they're trying to figure that out. So they give us the blood types. We got Mr. Smith, blood type O, and Mrs. Smith, blood type AB, and Mr. Jones, blood type A, Mrs. Jones, blood type B, and then we know what the babies are. Baby X is blood type AB, and baby Z is blood type B. And they're trying to figure out, does baby X go with the Joneses or the Smiths, or does baby Z go with the Joneses or Smiths, and how do you figure that out? So the first thing you do, if you don't have it, you draw your Punnett squares. In this case, we're going to need two separate Punnett squares because we have two sets of parents, the Smiths and the Joneses. So I'll start with Mr. Smith, who's blood type O. Remember, blood type O is recessive, so if you're recessive, you have two copies of the O allele, and in blood type, because you have multiple alleles, we often use this I, this letter I, and if it's a lowercase I like you see here, that means they have the recessive copy. If it's dominant, what we'll do is we'll use an uppercase I and a superscript A or B. So Mr. Smith is blood type O, homozygous recessive for blood type O, he looks like that. And Mrs. Smith, who has the codominant A and B, is going to end up looking like that. So you have A and you have B, so you have Mr. Smith and you have Mrs. Smith. And just to remind you, remember the Punnett square that you see here, these are designed to show you all of the possibilities of what could happen. You can use them to determine the odds of certain events occurring. It doesn't really matter if Mr. Smith goes here or goes here and vice versa. It doesn't matter the order in which you put the A versus the B. The only thing that matters is you have all the possible choices here and all the correct possible choices here, and then you're going to end up crossing them and say, well, what if this sperm from Mr. Smith here fertilized this egg, what would you get? Okay, now let's go over and look at the Joneses for a second here. In the case of Mr. and Mrs. Jones, blood type A and B, we know that they have this IA and this IB. So let's say this is Mr. Jones, this is Mrs. Jones. The problem is, though, we don't really know what would go here because you could have either the lowercase I or you could have the IA. You could have either one of those there. And the reason for that is, remember that A is dominant over O. So a person with blood type A, if they give you the phenotype and tell you the phenotype is blood type A, the problem is to figure out the genotype. You don't know what that other allele is going to be, because it could be a little I, which represents the O allele, or it could be IA, just like this one. Either one of those would give you blood type A. The same thing happens with Mrs. Jones. She is I superscript B, like that, and you don't know what goes down here. So we can't really go any further on this one, except we could cross that and know that they have blood type AB. They could have a baby blood type AB. So let's go back over here. Let's finish this Punnett square over here and say, okay, what happens? What would happen if this sperm fertilized this egg? You would get this baby right here. This baby would have blood type A, because they have uppercase I with the A, and then they have the recessive allele here. Remember, A is dominant over O. So this baby would have blood type A. This baby would also have blood type A. This baby would have blood type B. This baby would have blood type B. Now, on this side over here, this baby right here would have blood type AB, and once again, we don't know the rest of these because we don't know what would go there, and we don't know for sure what would go there. But if these are our only choices, and this is what we're left with at the end, what you can kind of figure out is you can go, well, baby Z then with blood type B probably must go with the Mr. and Mrs. Smith right here. And the reason for that is if you look at baby X, and if those are the only two babies, and these are the only two parents, and it has to be one or the other, baby X, these people can't have a baby like baby X, right? So baby X with blood type AB, there's no way that Mr. Smith with his blood type O and Mrs. Smith with the AB could have that baby. Now, can these people have that baby? Well, we've already determined that's true, so that could work out. Depending on what was here, if this was lowercase i's, if those were both i's, they could also have a baby with blood type O, a baby with blood type B, and a baby with blood type A. They could have all your combinations. Or if this was IB, I'm sorry, yeah, if this was IA and this was IB, then they would all be just like this one. They would all be codominant A and B. So in this particular case, it turns out the one that really helps you the most in figuring this out are the Smiths with their blood type O. Because with Mr. Smith in particular, his blood type O, it really limits any contributions of genes by the other parent, because whatever the other parent is going to bring anything that's dominant on the other parent is going to show up if it's inherited, because Mr. Smith only has these two recessive genes in this case. So at the end, baby Z belongs to Mr. and Mrs. Smith, and baby X belongs to the Joneses.